Intro, music. Black hole is a region of space where matter has condensed to such a high density that the gravity at its surface, the surface gravity, is so high that you cannot escape it even at the speed of light. You are forever trapped. It is the fabric of the space-time continuum warped back on itself, and what you fall in. The fact that these cosmic objects exist boggles the mind. They are cosmic objects so counterintuitive, massive and strange they have been considered hypothetical objects for the longest time in the history of science. In his general theory of relativity in 1916, Albert Einstein first predicted the existence of black holes, but it took a German artillery lieutenant, Schwarzschild, fighting on the front lines of the First World War, Karl Schwarzschild, to provide the first exact solution to Einstein's field equations of general relativity, where he described how space-time is walked outside a spherical object. His mathematical solution shows how it becomes harder for matter to escape the gravitational field of ultra-high dense stars. Eventually there comes a point where event horizon, every particle, even light, becomes gravitationally trapped. Once matter passes this point, there is no escape. This point of no return is called the event horizon, and something completely bizarre happens once you approach and go past the event horizon. Time itself slows down to a complete standstill. This is why early physicists studying these mysterious objects sometimes called them frozen stars. The phrase black hole was only popularized by American physicist John Wheeler in 1967, when it was reportedly suggested by a student at one of his lectures. Wheeler also best summarized in layperson terms the field equations, where he described it as space-time tells matter how to move and matter tells space-time how to curve. It took decades to accept black holes as history, anything but a mathematical curiosity. Most of the leading theoretical physicists of the 20th century insisted that these strange objects could never form in reality. Arthur Eddington said, "I think there should be a law of nature to prevent a star from behaving in this absurd way, but black holes are all too real." Though it is understandable that even world-leading experts in general relativity dismissed them as mere mathematical curiosities. After all, the phrase black hole caught on for a reason. They are pitch black as they emit no light, so how can you take a phenomena seriously if you can't directly observe it? How do you see the unseeable unseeable? When an ultra-high dense star runs out of nuclear fuel, it begins to collapse on its own weight. If it's massive enough, say 10 to 29 solar masses, its collapsed core will turn into a neutron star. A way to break your mind is to try to visualize a star that's 10 times the mass of the Sun with the size of a city. That's a neutron star. If it has a mass greater than 20 times the mass of the Sun, even the proton degeneracy pressure will not suffice to keep the mass from imploding and collapsing into a single point of infinite density, forming a black hole. Black holes are detected as surrounding X-rays. Material like gas is funneled by the force of gravity into a disk around the black hole. The gas molecules in the disk swirl around the black hole so fast that they heat up and emit X-rays. In the 1960s, X-ray astronomy was developing rapidly with a series of rockets and satellites launched into space. In 1964, astronomers discovered one of the brightest X-ray sources in the sky in the constellation Cygnus. In 1970, NASA launched a Haru X-ray Explorer satellite that provided detailed observation and measurements for this strange X-ray radio source. It showed SIG X1 had rapid variability on timescales shorter than a second. The mission was also able to calculate the mass of this mysterious object, 15 solar masses, far exceeding any theoretical limit for neutron stars, making SIG X1 a prime candidate to be the first stellar black hole ever detected. Next week we will explore far more ominous black holes than stellar ones. Subscribe and ring the bell to be notified about part 2 of the black hole series. Thanks for watching.